So welcome guys. In my previous videos I've done about the introduction part of the second shift theorem. Here now we are going to continue with the working, whereby we say that the first thing and the most important thing that we need to understand is about the second shifting theorem formula. When it comes to the formula, we have the Laplace transform of t to the power of n. Our function f of t is going to be equals to 1 raised to a power of n d raised to a power of n ds to the power of n. We come and multiply by the function f of s. Let us now get into our example here using the same formula. The Laplace transform of our function t squared cos 4t is going to be equals to -1 raised to the power of n. The power of n is going to be 2. We come and multiply by d squared all over ds squared. The Laplace transform of our function f of t is going to be now the f of s. Now, the Laplace transform of cos 4t is equals to s all over s squared we add to 16, to mean that we are going to have now here s all over s squared we add to 16. That is the Laplace transform of now our function f of t, which is equals to f of s. Let us now do our differential here, because it is the differential of our function here. And by carrying out the differential of this function, we are going to use the quotient rule, whereby here we are going to have our u and here we are going to have our v. We understand that d with respect to ds is equals to, using the quotient rule, v du with respect to ds, we subtract from dv with respect to ds, everything will be all over v squared. Our u will be equals to s. Our du with respect to ds is equals to 1. Our v, from here we are going to have s squared we add to 16. Our dv with respect to ds is going to be equals to the differential of our function here, 2s. Here we are going to have 0. Let us now get into our working, because we have all the parameters that we need here. S all over ds is going to be equals to our v. V is equals to s squared we add to 16. Du with respect to ds 1. We subtract from u. Our u is equals to s, and our dv with respect to ds is equals to 2s. Everything is going to be all over v squared. Our v squared is equals to s squared we add to 16, but everything now will be squared. Let us simplify what we are having on the numerator, and by simplification of what we are having on the numerator, we are going to have is equals to s squared we add to 16. We come and subtract from 2s squared, everything all over s squared we add to 16, everything squared. Here on our numerator now we are going to have 2. Here we are having a negative of 2s squared. We add to a positive of s squared, to mean that here we are going to have a negative of s squared. We come and add to 16 all over s squared we add to 16, but now here everything will be squared. That is our first differential. Since it was d squared, now let us get into our second differential. It is more of a successive differential, whereby here now we are going to have our u, here now we are going to have our term of v. We understand that u is equals to from here now we understand that u is equals to negative s squared we add to 16. Our du with respect to ds is going to be equal to our differential here, negative 2s. Our v is equals to s squared we add to 16, but everything now will be squared. Our dv with respect to ds is going to be equals to, here we come and differentiate our function here. We are going to have 2 into s squared we add to 16 to the power of, we are going to subtract 1 to this power, and we are going to have it this way, and then we come and differentiate whatever we are having within the bracket. And when we differentiate our function here, we are going to have 2s, because this one is going to be a 0. This is what we refer to as the chain rule, whereby you must first differentiate with respect to the power. So I come, I drop the power, I rewrite everything within the bracket, and then to the power I subtract 1. So it was 2. When I subtracted 1, it is going to be 1. So there is no need of writing. And then I come, I differentiate whatever I'm having within the bracket. And when I differentiate whatever I'm having within the bracket, I'm going to have 2s. Here I'm going to get a 0. So this is my answer. Let us now get back into our working, whereby still using the quotient rule v. My v is going to be equals to s squared I add to 16, but everything was squared. Du with respect to ds is equals to negative 2s. I subtract from u. My u is equals to negative s squared I add to 16. dv with respect to ds. dv with respect to ds is equals to 2. First here I'm going to have 4s. 4s into s squared I add 16. And everything is going to be all over v squared. My v squared, I'm going to have s squared I add to 16. But since it was squared, so I'm going to have to a power of 4. From this point now, let me work out the numerator. On the numerator now, I'm going to have a common function of negative 2s into s squared I add to 16. This is what I'm going to factor out, because here I have a common term of this and I have a common term of this. Here I have a common term of negative 2s. Here I have a common term of negative 2x. It is possible to get it from here. This negative, I'm going now to factor them, all of them outside. So here I'm going to have s squared I add to 16. It was power 2. Have factored out the first one. So I'm going to have s Just like that, this one I've already factored out. I'm going to have an addition of this one I've factored out. Here now I'm going to have 2s into negative s squared I add to 16. Everything is going to be all over. I was having here now s squared I add to 16, but now here I'm going to have power of 3. Here I'm going to have s squared plus 16. These two are going to cancel out, and when they cancel out now, here I'm going to have d squared is equals to negative 2s into s squared I add to 16. We subtract from. Here I'm going to have 2s cubed I add to here 32s, and everything is going to be all over s squared I add to 16, but everything now will be cubed. At this point now on the numerator, I can come and have negative 2s into, on my numerator now I'm going to have negative 2s cubed I add to s squared, we add to, 32s, we add to 16, and everything is going to be all over s squared, we add to 16. Everything goes to a power of 3. And this is how you go about finding the Laplace transform of a function given like that. You must first do your first differential, second differential, and then you leave your answer into its simplest form.